This video is going to piggyback on the previous video that I posted over polar coordinates. Okay, now we're still going to be using some of the same formulas that we have with polar coordinates, but this time we're going to be looking at equations and how we can switch a full equation into polar form, or maybe switch a polar equation to rectangular form, going back and forth. So, first up, it says, write this in polar form. Well, I know from my pre-Cal A days that this is just a circle with a radius of 3. Now, knowing that, I'm willing to bet the answer down here is r equals 3, right? Let's talk about how to get there. This x squared plus y squared is equal to r squared. Okay, we had that formula yesterday when we converted points. X squared plus y squared equals r squared. And if I just take the square root of both sides, I get r equals 3. Now, I'm going to introduce you to some graphs. I assure you, you do not have to graph in the practice set that I'm giving you tonight. We're going to save all the graphing for a future video. But r equals 3, just kind of think what that would mean. It would just be a circle. Doesn't matter what the theta is, it's just this circle along the radius of 3. Did I count right? 1, 2, 3. I did. Which makes sense, because if I had an xy plane over the top of this, I went out 1, 2, 3 in each direction. 1, 2, 3, and drew a circle on the xy plane. Okay. So I'll be kind of showing you some of these so you can kind of relate them, but definitely don't have to graph anything yet. The graphs are coming, right? Not today. Okay, so let's try this one. There's not just a whole bunch of tricks I'm going to try to throw at you. On this one, the x squared plus y squared is still equal to r squared. And 6 is going to equal, I just have y right there. But I remember something from the previous day. Hold on, there's like a jackhammer going down the hall. I'm going to hit pause and come back in just a second. All right, I don't want to start the video over, but you might hear it again. It's a propane buffer. They're buffing the floors out in the hall with this buffer that's hooked up to a propane tank. Anyway, the floors will look good whenever you guys come back. So if it fires back up again, I'll hit pause and then we'll restart this video. All right, need a little break in the monotony maybe. All right, so we're talking about this y right here, and this y is going to equal, we said it was equal to r sine theta, and that's exactly what I want to plug in right here. Can you guys hear that? Fire back up again. Now, this is in polar form. If I could clean it up a little bit. Okay? So, I could, let's just go ahead and get rid of the parentheses. I don't know why they're there. Now, look, I have a common factor of r on both sides. So I'm going to do this a little bit differently than the book does. I'm just going to divide both sides by r. Because dividing both sides by r, all that's going to do is get rid of this little point that's right there at the origin. I really don't need. I'm looking for the whole graph of eventually what this would be. So I get r equals 6 sine theta. And this is going to be one of the first things that we graph next week whenever we graph these polar equations. That is still going to be a circle, but it's not centered at the origin anymore, or the pole. Instead, it's got, I think it comes up 1, 2, 3, 4, 5, 6. Perfect. It's a circle. Oh my word. I want you guys to try to draw a circle on top of other circles and make it look like a circle. But yeah, it's a circle that sits on the pole right here and looks like this. More on that coming. Again, don't worry about graphing tonight. Hey, what about going the other way? What if I say, well, here it is in rectangular form, take it to polar form? Okay. So we had those equations for y. I just erased it, but y was equal to r sine theta, and then x is equal to r cosine theta, right? So I successfully have gotten rid of my x and y. I'm going to hit pause again. Here comes the floor buffer. All right, he's gone. So, all right, what do we need to do with this? I'm going to get everything that has an r on one side. I want to show you how different this can look and how the book is going to want the answer. Okay, so I'm going to subtract off is 3r cosine theta for both sides. Just leave 2 over there. Okay? So a lot of times, whenever we work a rectangular equation, we like to have that answer left as y equals something, just like we have here. Well, the opposite is true for polar. We like it left with just r equals something. And so the way that you're going to see this written, either going forwards or backwards, is going to be 2 over sine theta minus 3 cosine theta is equal to r. If you guys can hear that floor buffer, I apologize. If this video doesn't turn out good, I will delete it and you won't even know what happened. Right, if you can't hear me well. Are you curious what it looks like? Where are we at? Right here? Well, I know that graphing this would be a real booger, but y equals 3x plus 2, that's just 1, 2. It's got a slope of 3. We're just talking about a line that looks something like this. We can graph straight lines on these polar coordinates, all right, or these polar graphs. So that's what this would look like. All right, I'm going to let you play with this one. So we're going to hit pause, and then you solve this one. Don't worry about graphing it. And see if you can get this back into polar form. A little trick on there. I added the x squared over. So sometimes you need to force this into what r squared would be. All right, so the x squared plus y squared. And yeah, it's just a circle again that's almost 2 units in radii. Like I said, sometimes you have to force it. Okay? So you're thinking, well, I don't have anything with secant. But remember that secant is just 1 over cosine. And so if I multiply both sides by cosine, floor buffer, this hopefully looks familiar. And I've got it as a rectangular equation. X equals 2. Just come over to 2 radii. It goes like this. And that's what the graph of that would look like. I think part of the homework tonight asks is what conic section does it follow? Is it a line? Is it a parabola? Is it a hyperbola? And we haven't talked about that yet. And so I'm not really worried about that. If you want to go through and state whether it's a line or not, that's great. I'm more interested in you just doing these conversions that I'm doing over here on the left side of each page. All right, we're almost there. Again, this one's going to force into you forcing it into the formulas that we have. For instance, I'm looking at this and I was like, man, it sure would be nice if that was an r squared. Because then I would have x squared plus y squared. And I look at it and I'm like, well, it's missing an r right here. Because if I had r sine theta, that would just be my y. Well, I can't do that. All I did was multiply both sides by r. If I multiply this side by r, I'm able to have r sine theta, change it to a y. If I multiply this side by r, it becomes r squared. This is good enough for me. If the book does anything extra with it, that's on it, but this is going to be full credit. There's several different answers I will accept on the quiz and the test coming. I've got one more. It's going to be a short video. Oh, we don't have any more. Was that really it? Okay, so we're going 17 to 39 on. Some of these are very basic and very easy. So I don't plan on going really heavy into this as far as some of the harder problems. So work these out. Have questions ready for me for the Q&A, and I will see you guys next time.